Hello everyone, welcome to my tutorial series on programming in C. Today we will learn file handling in C programming. Files are used for storage of data permanently. Data in the file is accessible even after execution of the program in which it is created. Files also allow storage of bulk amount of data. The files makes it easier for the programmer to read bulk amount of data from files rather than entering it manually. So if a program requires a large amount of data to be entered manually, we can replace the process by usage of a file. We can read the data from the file directly using file reading functions. Pointers are the tool that are used for accessing the files. That is, all the files will be pointed to by some file pointers. So we need to declare a pointer of type file to point to a particular file. The syntax of declaration is file star file pointer, similar to we define a variable. So file is the type, file is data type which refers to file. Star represents it is a pointer type of variable, and this is the name of file pointer. A special character EOF, that is end of file, is used to denote the endpoint of the file. Example of the declaration is file star FP, where file is the data type which represents files. Star is used for representing a pointer, and FP is the name of the file pointer which is used for pointing to the file. Different file operations. So we have different file operations like open, close, read, write, and append. The first function is open. So before performing any operation, we have to open the file, just like we double click and open a file. So the syntax for opening a file is fp equal to fopen file name comma mode, where fp is the file pointer, the pointer which points to that particular file. File name is the name of the file, and mode is the mode in which it is opened. That is, the mode can be R, W, A, R plus W plus A plus etc. These are some of the modes, and some other modes are also supported. R refers to read, W refers to write, A for append, R plus for read and write, W plus also for read and write, A plus is for read and append. So we can select the appropriate mode when we open the file. Second operation is close operation. So after performing some operations, we have to close the file by using the syntax fclose the file pointer. If a number of files are opened, we can close all these files by using fclose all. The third function is read function. In read function, we can read the file content by using different file handling functions like fgetC, fscanf, and fgetS. The file must be opened in read mode while we perform the read function. Fourth operation is write operation. Write operation. In write operation, the file handling functions are fputC, fprintf, and fputs. These functions can be used for writing some content to the file. So it must be opened in write mode, W mode, before writing something to the file. Next operation is append. Append stands for adding some data to an existing file. That is, if a file is having a lot of data and if we want to add something to that file, we can use the append function. The same functions that are used for writing something to a file can be used in append function also, but it should be opened in append mode in order to add some data. Otherwise, if we are using the write mode, it will replace the existing contents. When we open the file in the write mode, if such a file doesn't exist, it will automatically create that file. Opening, reading and closing a text file. So these are the examples of opening, reading and closing a text file using different functions. First we shall see scanner for reading some data from an existing file. So my data file is datafile.txt having these contents. So using fscanf I am going to read from the file. So for that I am first declaring a file pointer of file type. Then to read something we need to have some buffers for storing the read data. So the buffer is here, read of 100, that no sorry, content of 100. Content of 100 is a buffer which can hold 100 bytes of data. Next we have to open the file, the data file.txt file in write mode. So that is f open data file.txt comma r. Next we are going to scan the content using fscanf function. The format is like this. First we have to specify the file pointer, the pointer which points to the data file. Next the format specifier percentages and the buffer name content. So using fscanf function we write some data from the file. We shall see what is the output of this fscanf. To understand what is read by fscanf, we need to use the putas function to display the content to the console. So putas content will display this detail. So this is the output. So you can see it had a lot of data inside this, but the fscanf function read only the first word, because after the first word there is a space. So the fscanf function can read only up to a space, a tab, a new line character or any white spaces. So next we shall see how fgetters can be used. Here also the first three lines are the same, declaring the file pointer, declaring a character array, then opening the data file in read mode. Now the format of fgetters is different. First the buffer is represented, then the buffer size is represented. Here the buffer size, in the declaration also the content, the size of the content is 100, but we can have the buffer size here up to 100. That is, if content can hold 100 values, the buffer, the value that it read from the file can be up to 100. So we can specify any value based upon our requirement up to 100. In this particular case 100. Next the file pointer, the pointer which points to our data file. Now to understand what is displayed using what is read using fgetters, we are using the putters function to display it to the console. So putters content will display the first line of the data file. That means the fgetters function can read up to the new line character. So when it encounters a new line character, it stops reading. Now using fgetc, that is, we are going to read character by character using fgetc. So for that, the first line is same, file star fp, declaring a file pointer. Next, in this case, fgetc function is used for reading only a single character. So we must do it in a loop to read the entire data. So I am declaring the buffer. Here the buffer size that we require is only a single byte. So I am declaring a character char c and opening the file in read mode. So to read all the characters, we are going to use a loop inside which we will be reading using the fgetc function. So in a loop with condition while true, within these two parentheses it will be running in a infinite way till it encounters the break, because this while loop is an infinite loop as the condition given is 1 or true. So it is reading c equal to fgetc of fp. So it will read the first letter s. Initially it will read the first letter s. Next it will check if c is equal to eof. Eof is the end of file. So the red value is not the end of file, so it will go out of if. That is, the break will not be executed. Break statement is not executed, and it prints the value of c. That means s is read and s is printed on the console. So first s is read. Next it will go back here, again read the next character. So after s it will advance to the next character of the file. That is, the file pointer will advance to the next byte. So the next one is a. So it will read a as c is not equal to end of file. C is equal to a now. So it will go out of this if statement and it will print the second value a. In this way it will read all these values, including the white spaces, new line characters, tabs, everything. And at the end it will encounter a end of file character. That is, in the text file a character which is called end of file is automatically inserted. So at the end of file there will be a end of file character. So it will read that end of file character. When it encounters an end of file character, the break statement will be executed and it come out of the loop. And at the end it will execute the fclose fp to close the file. I forgot to say, in the previous two cases also the fclose operation is executed. So we can read the entire file not only using fgetc, we can have all these data read using fscanf and fgetters, but we have to do it in some loops based upon the number of words or number of sentences. Next is reading an integer from a text file. So this text file contain different integer values 101, 102, 103, 104, 105. You can see different arrangements of the numbers. There are some new lines, some spaces, some tabs. So in such a type of data file, how we can read the integer values? So reading the integer data from a file. The first three steps are same. Declaring a file pointer. Then here the buffer is an integer. So integer A. The buffer used is an integer type. So I am declaring A as integer for storing the data read from the file. Next, the operation is fp equal to f open data file.txt comma r for reading the integer values. Next is fscanf. I'm reading using the fscanf function. The first parameter is file pointer. Second parameter is the type specifier. Here we need to read integer, so we use %d. Third one is the buffer, and we have to specify ampersand a, similar to what we use in a normal scanf, because the data will be stored in the location specified by the ampersand symbol. That is, ampersand symbol is used for accessing the location of a particular variable. Next, we are printing the read value. Printf %d comma a, and I am closing the file. So this will read only the first content because we have used only a single fscanf. So the result is like this 101. So it prints only the first integer. That means it will read only up to this. This entire data is a single integer file, integer data. 101 is a single integer data that is read and printed. And if we want to access all these data, that is, there are 5 numbers, we are going to sequentially access these data from the file. So here also we are using the same function fscanf, but we will be running in a loop. So how we can perform this function? So when we read the integers, it will not read the spaces in between, spaces, tabs, or new lines in between. These white spaces are actually separated for the different integer file, integer data. So this operation can be done, that is, reading all these integer data can be done using a while loop in which I will check for the end of file. I will read the integer data till the end of file. The rest of the operations are same, and the fscanf is run in a while loop, and each data that is read is printed. So the loop is while fscanf fp %d ampersand a not equal to end of file, printing the read value. So in the first iteration of the while loop, the first content, that is 101, is read and 101 is printed using this printf. In the second iteration, it will skip the new line and go to the second value, that is 102 is read and printed. So 101, 102. In the next iteration, it will go to the new line and will read the third value and that will be printed. Then it will skip the white spaces in between and read the fourth value, and that is printed. And there is actually a tab in between 104 and 105. It will skip that tab and read the next integer value 105, and that is printed. So after 105, it represents the end of file. So this portion, actually there will be an end of file character. So when it reads the next item, it is equal to end of file. So it will exit the while loop, and at the end we will use the close fp for closing the file. So in this way we can read integer data from a text file. In a similar way we can have floating point numbers also. Next is writing to a text file. Writing some data to a text file. So for writing also we need to declare the file pointer. F is a pointer pointing to our data file. So here no such file exists. We are actually creating such a file. So I am declaring two variables, that is x is equal to a and y is equal to 70. That is, these are initialized to a and 70. X and y are initialized to values a and 70, and I am going to write these values to the text file. So for that this is created. The first operation is fp is equal to fopen data file.txt comma w. Here not, it is opened in write mode. Next I am going to print some content to the text file. So when this function is executed, fp is equal to fopen data file.txt comma w, the file will be created if such a file is not there in the area in which we write the program. So if path is not specified, the file will be created in the same folder in which the program is written. So please note, if such a file is not existing in our folder, such a file will be created in write mode. Next, using the fprintf function, I am writing some content. Using fprintf, the format is first the file pointer, then this content is written using printf. So whatever written as the second parameter, that will be printed. Similar to the printf function, within the codes whatever we write will be printed. And if some type specifiers are there, that will be replaced with the value of the next parameter. So the next parameter here is x, and the value of x is equal to a. So it will be printing this content is written using fprintf x is equal to a, and it will jump to the new line because there is a slash and escape sequence at the end. So this line is written in the data file. This content is written in the data file. This content is written using fprintf x is equal to a. Next, I am using the fputters function to write some value to the data file. So the function is like this: fputters. Here whatever written within the codes will be printed in the file, written to the data file. Within the codes whatever we write will be printed. So this content is written using fputters. And we have to specify the file pointer also here. And next function is fputc. So we have seen two functions, fprintf, fputters. Next fputc, which is used for writing character by character. So if I write fputc fx comma fp, it will write the value of the variable x, that is equal to a. Next one is fputc slash and comma fp. That means it will go to the new line. So after a, it will go to the new line. Next fputc x comma fp. Here x is in quotes. That means x is taken as a character constant. So x itself will be written there, not the value of x. X is now a character constant as it is within the quotes. So x itself is written there. Again it is printing a slash n, so it will go to the new line. After x, it is going to the new line. And at the end, I am printing fputc y comma fp. Y comma fp is not printing the value of y, right? It is equal to 70. But actually it is printing the value of y itself, because the 70 stands for the ASCII code of the capital letter F. As it is declared as character, writing the value of y will display the actual character which corresponds to the ASCII value 70. So instead of 70, it is printing F. So at the end of these operations, the file is closed. Next, appending data to the text file. That is, we are going to add some data to an existing file. So in this example, I am going to write some data to the previous file that was created using the write function. This file will be used for our example. So this is the file in which the portion up to F is written. To append something, only difference from the write mode is we have to open the file using the append mode. Instead of write mode, we have to use the append mode. If we use the write mode and do this operation, this file content will be replaced by the new content. But as I am using the append operation and printing this value fprintf, this content is added with the file. It will be added along with the previous content. So this is the end of the previous file. So after appending, it will append a slash n first. That is, after f, it will go to the new line. And this content is added with the file. This content is added with the file. Now this portion is the end of the file. And I am closing the file. We will continue with the inbuilt file handling functions in the next video. So thanks for watching, and if you have any doubts, please ask in the comment box below.